Your smartphone can now recognize your face in milliseconds. Your laptop can run AI assistance locally. And your car can detect pedestrians faster than you can blink. What's powering all of this? It's not just the CPU or GPU you already know. It's something purpose-built for intelligence, the NPU. An NPU, or Neural Processing Unit, is a specialized processor designed specifically to accelerate artificial intelligence workloads. Unlike a CPU, which excels at sequential, general-purpose tasks, or a GPU, which is optimized for parallel graphics rendering, an NPU is architected from the ground up to handle one thing extremely well: the math behind neural networks. At the heart of every AI model, whether it's a voice assistant, an image classifier, or a large language model, is a deceptively simple operation. Multiply a set of inputs by a set of weights, sum them up, and pass the result through an activation function. Repeat this billions of times per second. This operation is called a multiply-accumulate, or MAC. NPUs are built around massive arrays of MAC units, thousands of them working simultaneously, making them extraordinarily efficient at this specific computation. But raw performance isn't the only story. The real game changer is efficiency. Running an AI inference task on a CPU might consume 10 to 20 watts. A GPU could burn 150 watts or more. An NPU can perform the same task using less than 1 watt. This dramatic reduction in power consumption is what makes on-device AI possible, without draining your battery or burning your lap. NPUs are now everywhere. Apple's Neural Engine, first introduced in the A11 Bionic chip, processes Face ID and computational photography. Qualcomm's Hexagon NPU powers on-device AI in Android flagships. Intel's AI Boost and AMD's XDNA architecture bring NPUs to mainstream laptops. And in automotive, companies like MediaTek and NVIDIA are embedding NPUs directly into SoCs for real-time driver assistance systems. Even data centers are deploying dedicated NPU inference chips to handle AI at scale. Inside an NPU, you'll typically find a large systolic array or tensor core cluster. These are the MAC engines. Surrounding them is a generous pool of on-chip SRAM, because moving data from external DRAM is slow and power-hungry. A DMA controller streams weight matrices and activations directly into these buffers. A lightweight control processor issues vector and tensor instructions. The entire design minimizes memory bandwidth usage and maximizes computational density, what engineers call TOPS per watt, or tera operations per second per watt. As AI models grow more capable and more personal, the demand for on-device inference will only accelerate. The next generation of NPUs will support larger models, mixed precision computation, and even in-memory computing, where data is processed where it's stored, eliminating the bottleneck between compute and memory entirely. The NPU isn't just a chip upgrade, it's the foundation of ambient intelligence. From your pocket to the cloud, NPUs are quietly redefining what computers can do, not by being faster, but by being smarter about how they compute. That's the NPU.